In 2024, AI agents are poised to become a significant development in the field of generative AI. To understand AI agents, it is essential to first recognize the major shifts happening in AI, particularly the move from monolithic models to compound AI systems. If you are new at this channel, please subscribe for more AI-related updates. I regularly post updates related to AI. Traditionally, AI models have been limited by the data they were trained on, which constrains their knowledge and the types of tasks they can handle. Furthermore, adapting these models is challenging, requiring significant investment in data and resources to fine-tune them for specific needs. To illustrate, consider the task of planning a vacation and determining the number of vacation days available. Feeding this query into a standard model would likely result in an incorrect answer because the model doesn't have access to personal, sensitive information like individual vacation data. While AI models can perform useful tasks such as summarizing documents, drafting emails, and generating reports, their true potential is unlocked when integrated into broader systems that interact with existing processes. A compound AI system addresses this by connecting the model to external resources, such as a database where vacation data is stored. In this setup, the model can generate a search query, retrieve information from the database, and then produce a correct response. This approach highlights the advantage of system design principles, which recognize that some problems are better solved by combining multiple components. Such systems are inherently modular, allowing for the integration of various models, tools, and programmatic elements, making it easier and faster to adapt to new tasks compared to merely tuning a single model. One well-known example of a compound AI system is Retrieval Augmented Generation, RAG, where the system retrieves relevant information to enhance the model's responses. However, these systems are typically limited by their predefined control logic, which dictates a specific path for answering queries. For instance, a system designed to query a vacation policy database will fail if asked about the weather, as its control logic is narrowly focused on vacation-related data. This is where AI agents come into play. Unlike traditional systems with fixed control logic, AI agents use large language models, LLMs, to manage the logic, benefiting from the significant improvements in LLM's reasoning capabilities. These models can break down complex problems, create a plan, and adjust as needed, effectively acting as the brain of the system. This agentic approach contrasts with the more rigid, programmatic systems, which follow predefined instructions without deviation. AI agents combine several key capabilities. First, they possess reasoning ability, which allows them to plan and think through each step of a problem. Second, they can act by leveraging external tools, pieces of software that the model can call upon to execute specific tasks. These tools might include web search functions, calculators, code snippets, or even other language models specialized in tasks like translation. Third, AI agents have memory, enabling them to store and retrieve information from previous interactions, which helps create a more personalized experience. One popular method for configuring AI agents is the React framework, which combines reasoning and action. In this setup, a user query prompts the model to think through the problem, plan its approach, and decide when to use external tools. The model then assesses the outcomes, iterating on its plan until it reaches a correct solution. Consider a complex query like determining how many 2-ounce sunscreen bottles to bring on a vacation to Florida. An AI agent would break down the problem into several steps: retrieving vacation days from memory, checking the weather forecast for sun exposure, consulting a health website for sunscreen dosage recommendations, and performing the necessary calculations. The agent's ability to explore multiple paths and iterate on the plan makes it highly adaptable to complex queries. As compound AI systems evolve, they are becoming more agentic, with AI agents representing a sliding scale of autonomy. For narrowly defined tasks, programmatic approaches may be more efficient, as they follow a fixed path and deliver consistent results. However, for broader, more complex tasks, such as resolving various GitHub issues independently, an agentic approach is more practical, as it would be too labor-intensive to manually configure every possible path in the system. Though AI agent systems are still in their early stages, they are rapidly advancing, particularly when combining system design with agentic behavior. Despite these advances, human oversight will remain crucial as these systems continue to improve